Okay, what is up? Hey, we are gonna be talking about state in Haskell. So yeah, I'll go ahead and get started, and just want to say thanks everybody for following along and for being supportive. And if you don't mind, giving a follow or a like, that would be much appreciated. So with that, let's get to it. So last time we did file IO. So we actually built out a simple app that actually does something productive. Isn't that something? So let's see. Let me get this. So last time we did file IO, and if I pass main and then no arguments, let's see. I think I have to load source course. What is it? File IO. And then I say main. We say please provide a file name, because that is the error that we said to throw. But if we do provide a file name, such as, let's see, hotkeys are all messed up. So let's go to reveal active file in sidebar. Yeah, so we have this files.txt, and for each line, there's the name of another file, and then we'll read each of those files and output it to the screen. So let's try that. Let's bump up the font a little bit. So if I say main share / files.txt, boom, there you go. We have the concatenated contents of each of these files. So that's pretty cool. So now we're actually starting to get somewhere. We're starting to do something productive. Oh, hey, Pete's here. Setup is looking pro. Well, thank you, man. I don't know if that's true, but I noticed you have the sick like translucent chat overlay, and so I need to get on that train, figure out how to do that. Okay, and here we go, off to the races. Let's do the first one. So what do we have here? So we have this new type state. I think my formatter no, it didn't. Okay. So but we have a new type state that's parameterized by 2 arguments, S and A, 2 type parameters. And then we do this thing. So this is like record syntax, if I'm correct. So it's like state has a state thing has like a run state attribute. Actually, I should look that up. Haskell record syntax. Like the record syntax is a little confusing to me. Basic syntax. Records are an extension of some algebraic data type that allow fields to be named. Okay. Let R equal this record type. So I guess then each record field names. Okay, so the field names. So then the field names become like functions that you pass the record type to, and it returns that field. Okay, because when I fumbled my way through these a while back, and I didn't understand the syntax very well. So, okay, cool. I think that's good enough. So let's see. So we have this state type, and it has this run state field, which is a function from this S type to a tuple of 2 values, one of type A and one of type S. Okay. run the state seeded with S and retrieve the resulting state. Okay. So it's like a state is a function, or is a thing that has a function or a field that you pass it some seed and it returns a state. So let's just throw it, as I am wont to do, I'm going to I'm going to throw a title in here. Get the lay of the land. Nathaniel, you pass its state and it returns a value in a new state. Ah, okay, so that's what the A is. A is some, yeah, okay. A state is a function from a state value S to a produced value A and a resulting state S. Okay. I think we'll maybe see more about that as we do the exercises. Thanks for joining, Nathaniel. I can't remember if I've asked you this already, but Nathaniel, what is your experience with Haskell? Do you use it just as like a hobbyist, enthusiast, or on a professional level? So you can change state over and over again, Nathaniel says. Okay. Yeah, so then, yeah, I could see how where this might go, where we have an initial state and we run the function, we pass in some current state and we get a new state and we take that and we pass it through again. Okay. So our whole here needs to be a new state. And yeah, okay. So I'm just going to call this lowercase s state and then see what this says. Okay. So now my to-do has changed from this type to just S to S. So I guess I just need a pattern match on this, or I need to run state on. Yeah, so I guess I would call run state on the state. Well, that's weird. Keyboard just crapped out. Like my backspace isn't working. Okay. So then, Nathaniel says Haskell's been a hobby for the last 20 years. Wow, 20 years. That's awesome. I bet you've seen a lot of changes in the language and in the community. So what's like some highlights? How, like, what's one major way Haskell, the language, has changed in 20 years, and what's one way the community has changed in 20 years? I bet it's changed a lot. Oh, monads. Yeah. Well, that makes sense because, yeah, old school Haskell didn't have monads, I guess. I've heard a few talks about, like, from Simon Peyton Jones and, let me make sure I'm getting his name right. Simon Peyton Jones? Yeah, the creator of Haskell, or the main kind of guy maintaining it. And then Phil Wadler and Bartosz Milewski, like talking about monads and how Phil Wadler like helped get monads introduced. That's pretty wild that there's these people that most likely will be in history textbooks, like computer science textbooks someday. And they're just like, yeah, you can like at them on Twitter. Nathaniel says, also back when I was first learning Haskell, I was using Hugs. Everything wasn't just GHC at the time. So Hugs, was that just a different implementation of the Haskell like spec? And now it's just like the GHC Glasgow Haskell compiler is like the de facto one. That's kind of what I've heard. Okay, so run state should return this thing. Or is S the first argument to run state? And it returns an AS. Let's see. Okay, I expected this type and it had this actual type. So that means that we just returned this tuple AS. So then there's this second function, right? If I do T second, then that should give me this B. So if I do second, like 1, 2, that gives me 2. So I'm going to do that. Hotkeys. Reload. Didn't like that. With actual type. Nathaniel has linked us to the Hugs wiki. Hugs 98 is a bytecode interpreter for Haskell. Successor to Gopher. Huh. That's funny. That makes me think of Golang. Mark P. Jones. So is Hugs just like not maintained anymore? Hugs 98. Okay. That's cool. I think that's a fun name. Hugs. Okay, so what's going wrong here? So couldn't match type with actual type. So without the second thing here, my function exec. Okay, my function exec has this type S to AS. Maybe I should say like something like this. I'm just gonna comment this out for a sec. To do okay, so now to do should just be an S. I have an S. That feels wrong though. Because if I just return S here, that doesn't feel right. So that compiles. Add test state, not state. Yeah, state test. Test exec test. Yeah, okay, that's definitely wrong. So then, yeah, maybe I need to do this. Let x equal run state in to do. Then I can see what's going on. So I need to return an S to S. I have an X, which is S to AS. Okay, so I guess I do need to do this syntax. Let me check. Yeah. So I do need to do this syntax where I'm saying like, supposing I had an S. Yeah, like supposing I had an S, then I need to return a different S, and presumably it's the one out of the state parameter I've been passed, this argument. So then this X, what is X? Nathaniel's probably like yelling at his screen like, it's so obvious. No. Yeah, so I'm feeling like I need to pass this S that I've supposed that I've had to this X thing. But that's what I was doing before, right? So then maybe I'll say I'm just going to say supposing, so whatever the result of X applied to S is, I'm going to pass into my new function here. I'm going to call that result Y and see what it is using this type tool. So Y, that's bizarre. So I thought X passing S to X would give me this tuple. Why is that not the case? In fact, I guess I thought this. What is state? Oh, state is an SA. So running this field accessor, I guess I'm going to call it, on state, does it give me this whole function or does it give me just this tuple? That's what I'm confused about. Chat is eerily silent. So yeah, so X is this whole function. So I'm thinking like calling run state on this state value. State has this type, state SA. Calling run state on this passes me this entire function, X. And then when I apply X to some S, then I was expecting that to be this tuple. Yeah, I was expecting, oh, maybe it's just, maybe it's just the, I think what it was doing was like passing X to this function instead of the result of X applied to S. So now let's try this again. Yeah, so now Y is this tuple. That's it. Run state has two input parameters. You're right. So run state takes a value of type state SA, and then its second argument is the current state. I guess that's what I'm getting confused about is like state. State is a function from a state value, S. So they're saying S is a state value. Then what do I call this thing? Like this state word is overloaded now because like this, whatever value of type S is a quote unquote state value. And then this thing, I don't know what to call it. I guess I call it a state record. Pete says, I got tripped up on Haskell record syntax for the longest time. Yeah, it's not exactly intuitive. So yeah, that helps me now. Thank you, Nathaniel. So it's like this run state takes two arguments. It takes a state record and a state value. That's what I'm going to call it. The canonical implementation of this uses M. M as like, as this thing, or M as this thing. Or this thing, M. I don't know. Whatever the case, Y is now this tuple, and I need this S out of it. So I could just say second Y, but I think I can do better than that. But I'm just going to go with that for a second. Okay, that compiles. Yes. Let's go. Exec test passed. Boom. There you go. Anyone hiring for Haskell, hit me up. Okay. HLint is saying, yeah, I don't need this S. Why not this? Yeah, so I can just say this function that takes the second value of y composed with x. And then it's probably going to tell me, yeah, just second here. Maybe I should challenge myself. So I think this is I'm gonna challenge myself to try to guess what HLint is suggesting. This is an easy one, but I'm gonna try to guess what this is before just like letting HLint lead me. So this is gonna be redundant brackets, almost 100% certain of that. So okay, second. So run X and then run second. That's pretty good. But then we don't even need X. We can just say run state. See, when I do Alt, it like does the Ubuntu thing where it like scrolls through. I don't want it to, because my hotkey for like moving over a word is Alt left and Alt right. And then, but once I let go of Alt, it enters that weird mode. So apologies. So yeah, so don't need these outer ones. I really should learn them. Oh, so yeah, like I don't need these brackets because it's right associative. Test. Yeah, that's one thing that I find really satisfying about this like typed whole driven development is you can just follow the path, like follow the types and get some kind of messy implementation. And then it's like refactoring is like, it just holds your hand the whole way. It feels great. I'm not even ashamed of it. Okay, so I guess what I'm wondering is, can I do edit reduction here? I don't think so. I think in order to do edit reduction, I would have to like compose. You know, it will tell me state IO. I mean, point free .io. Oh yeah, Nathaniel's pro. Well, I'll just show. Let's see if Nathaniel's right. Yes. No. Maybe I didn't go far enough. So I think this is the working. Yeah, this is the working version. Okay. So then if we pass that to state to point free IO. Yeah, then yeah, Nathaniel was right. Yeah, so I'm not going to do that because that just looks wonky to me. Second composed with compose run state. Yeah. I'm just going to leave it here. Okay. Make sure that passes. Okay, and we're done with our first exercise. Let's try and go a little faster. So run the state seeded with S. Okay, so exec is run the state seeded with S and retrieve the resulting state. And then eval is run the state seed with S and retrieve the resulting value. So then is it just going to be this, but first? Educated guess. Because we just need the first value out of this tuple instead of that one. Fist. Test. val test. Hey, there you go. No applause needed. Get a state where the state also distributes into the produced value. Nathaniel says, I think this is the clearest version. Exec ms. I'm going to copy that. Exec ms second run state ms. Okay. Yeah, so then that makes it more clear that exec is taking two arguments. This m, which Nathaniel said m is, that stands for monad, of course it does. So you run state on this, and then you give it some seed. Yeah, seeded with, or state. And then this is going to return the tuple that we were talking about and then get the second value. So let's reload, test, exec. Okay, that does pass. Yeah, that's nice. Maybe I'll do that for this version too. And just say first. Struggling with hotkeys. I'm gonna put that one there. So, oh, that's why eval wants me to say eval. But I don't want it to do a line break. There we go. So let's make sure eval still works. Test eval test. Yeah, cool. And then get let's see. As to Roth77, welcome to the stream, says, how about how about this? Is it isn't this called like the Bluebird or something? Bluebird combinator. Combinators. I think Astaroth is being cheeky. Bluebird. I don't think this is what I thought it was. Yeah, I know there's some like there's a special name for this thing. Blackbird. I don't know. So that, oh, is that a way to compose? Oh yeah, so someone was explaining this to me on the functional programming Slack. I wish I remember his name. Maybe I'll look it up, because he wrote such a thorough and helpful explanation. Yeah, I'm gonna actually put this on stream. So let me see, let's go to threads. So yeah, this is the functional programming Slack, which you can go to. So Gabriel, that's what Gabriel Lebec wrote me this really nice long explanation of some of the questions in a previous video, and talked about maybe it was later. Yeah, later in this thread. He says, astonishingly, a point-free way to define Blackbird. There you go, yeah. Astaroth, you're right. Blackbird is this mind warping exercise. So I don't know what to call this, like double compose maybe? Compose with compose. So I guess that Blackbird combinator composes a function that takes one argument with a function that takes two arguments. Is that correct? That would line up with what you're saying here. So second takes a single argument, which is a tuple, and run state takes two arguments. So in order to compose these two, yeah, I guess that's what point free was trying to tell us. Yeah, that's cool. I'm going to leave that comment there. Yeah. Thanks for that. Astrats, what about you? What's your experience with Haskell? Is it like a hobby or a professional thing? Commander Thrashton, how S Haskell? I don't know what that means, but welcome to the string. Did we test? Oh, wait, we haven't done get yet. Got distracted. Run state where the state also distributes into the produced value. So I guess this is like, my dog is licking my foot right now. It's really distracting. Oh, Commander Thrashton says, how does Haskell feel? Man, I think it feels awesome. I mean, it inspired me to want to do this stream, that's for sure. So, I mean, for those who are new to the stream, I basically started, I'm a Haskell noob, so I started on Learn You a Haskell, the free book online, and then I found this course, and there's a YouTube series by a guy named Brian McKenna, and he walks through quite a few of these exercises, and that got me started. And then I got through most of these, and then I said, man, this is so fun. And also I came across a lot of these questions that yeah, I think I don't know if it's true. I don't know if this is helpful to make this stream and like record it and put it on YouTube, but my hope is that because I'm a beginner going through it, that I don't yet have the curse of knowledge where you forget what it's like to learn for the first time. So I thought maybe it'd be good to record myself learning this for the first time, because it feels like Haskell, I mean, subjectively, in my experience, there was not a lot of beginner-friendly resources when I started. Like, I first tried a few years ago, and I kind of gave up, which I hear is a pretty common experience for people. So I thought, well, maybe if I make a stream of like me as a beginner going through this, maybe I'll ask all the same questions, or a lot of the same questions someone else would ask, and then I don't know. Mainly, I think it's fun. Astaroth says, oh yeah, ask Astaroth what their experience with Haskell was. Studying computer science first course was in Haskell. Nice. Quite a few years of imperative programming before that, I guess. Cool. But yeah, Commander Thrashton, how does it feel? I think it feels great. One of the reasons it's so fun for me is I feel like it's the closest I've come to feeling like I'm learning programming for the first time. I almost feel like I'm learning programming for the first time again. So I have the benefit of like, oh, I'm going to really enjoy this with intention, like, and think through it. And like, maybe that's part of why I wanted to record it, is like, I want to record this for, maybe I can mine the stream later for content for like blogs for beginner Haskellers, or make short videos like, what is the state monad, and something like that. Commander Thrashton saying, I learned some basics but wasn't too impressed, especially with all the type theory stuff. But I know that feeling. So is that how you still currently feel with Haskell, that it's just not too impressive, or are you saying that's how you felt at the beginning and now you really enjoy it? Be interested to know. So yeah, thanks for listening. Thanks for asking that, and thanks for listening to my spiel. So get is a state where, yeah, so we just copy the state S into this produced value A. So run state get 0 should return 0, 0. So it takes I'm going to follow this pattern that that Nathaniel laid out for us, and just keep rolling with that. So let's see. MS, and then I know I'm going to need to run state. Yeah, I guess I'm just going to follow this pattern because I know that basically everything, this will return the first element of the tuple, but yeah, so let me just I'm going to actually pattern match here. So I know I have like an A, and I'm going to call this an S prime. And I think I just wanted to say S prime, S prime. So I just want to throw this away, basically. And I'm going to test that. I know HLent is not happy with me. Okay, that did not work for sure. Not entirely sure though. Sure why though. So what if I do to do right here? No. Expected type state assess. Let's just take it back. So whenever I get stuck like this, I could just like try to guess what I'm doing wrong, but I think the easiest thing is to just like roll it back and kind of like start over with a simpler type tool. Okay, how do I completely clear this? So maybe chat's trying to help. Commander Thrashton says, I felt like I'm enjoying programming when I learned Lisp. I think Haskell's kind of nice. I would rather explore Idris when I have time. Yeah, I've looked into Idris. I actually tried to learn Idris, and I just it was too hard. So I just basically I felt like the tutorials basically assumed you knew Haskell. So I thought, well, I should do Haskell first. So yeah, I do recommend looking into Lisp at some point as well. Yeah, I have this book. Let's see, it's gonna take a while to come up on stream. The structure and interpretation of computer programs. It's commonly referred to as SICP, and it's Scheme, which is like a flavor of Lisp developed at MIT, and yeah, Lisp, lots of parentheses and whatnot. And actually, I have some buddies that are going through that book together, and I was trying to do that with them, meeting once a week, and also do this course, like stream this course, and I was like, oh, it's too much. I can't do it. So I'm hoping after I get through this course, maybe I can catch up with them. Maybe I'll stream the SICP exercises. Thrashton recommends Common Lisp. Scheme could work. Okay. So can anyone help me help explain? So it looks like I'm returning this type, and I need to return a state SS. Oh, I see. So before we were returning just an A, and now I need to return an actual like state type, not just like an S or an A or a tuple. So maybe what I should do is say yeah, so what I'm going to say is get ms, and then I'm going to say state to do. Maybe I should say well, no, I'm so close with this one. Let's see. I'm so close with this one. So this will return a tuple. I think I was nearly there. So this will return a tuple of A and S, I'll call it s prime. But I'm going to return, I'm going to ignore the a, and then I'm going to return a new state. Can I construct a state like this? Let's see, how do I construct a state? I think maybe to build a state, I need to use run state, or I need to like pass a function to. Yeah, maybe what I should try is state. Sorry, I'm not looking at chat for a second because I'm trying to think through this. Yeah, so I think this is how I construct a state. I use the state constructor and then I pass it some function. I don't think I have to like use this word. So let's see if this to do looks like it makes sense. Oh, but I'm accepting these arguments, so maybe I should take those out for a second. Yeah, okay, so that looks more. So in order to build like a state SS, I need a function from an S to a tuple of SS. So let's check chat. Can you show your code? You're creating a state monad that returns SS. Yeah, sorry I wasn't watching. I was like on a roll. It doesn't take arguments. Yeah, check this, the type of get. Wrap a function in state like that. Okay, yeah. Sorry, I feel like I should move my chat window to the other side of this manager thing so I can see it more easily. Yeah, okay, that's way better. Now it's like closer to my code. Supposed to wrap stuff. Okay, so yeah, thanks for bearing with me. So then this, oh, so then do I just do SS here? That seems like it might work. Maybe I was way overthinking it. Test, get test. Huh, that works. Okay. Yeah, thanks for bearing with me on that one. Okay, so yeah, I'm just going to delete that. No one needs to know about that. Put run state, a state where the resulting state is seeded with a given value. Okay. So run state takes two arguments. One is like the state record, and the other is the seed or the initial state. So then put one has the type S to a state S unit. So my guess is it's going to be similar to this, and I just put unit here. Put. Except get is not a function, so should I just do this, like supposing I had an S? S prime, and then this thing takes that S. But then that, isn't that the same as just mismatch brackets? I'm doing something horribly wrong here. Pete says, now you've got a choice. Which S do you keep? Indeed. Oh, I miss. No? I apologize for this, but I'm going to use a type tool. Okay, so this needs to be a state. I just need to return a state S unit. And in order to build a state, I do something like this. I thought that would work, but I'm now overshadowing this S, so I need to call this S prime, I think. And I'm actually wondering if I should throw this S away because, yeah, Pete's question is feeling potent now. Why are these brackets wrong? Do I need an additional? Yeah. Couldn't match type S with unit. Expected type state S unit. And actual type is state unit unit. I think this should be. I don't understand this type error, but I think it's because I need to do this and use the initial state because it says the resulting state is seeded with the given value. So we're turning the maybe. Oh, so now it's backwards. So let's look at the state type again. So it's state SA. So if we need a state S unit, then the unit should go here. Missing brackets again. S goes in the other position, yeah. Got confused on where the state is returned, yep. Okay, so that compiled. That's the other fun thing about Haskell is like when it compiles, you're like, yeah, it probably works. Or it's very close to working. Redundant lambda, yeah. Gonna do that. Yeah, so h1 is telling me to use const here, but I'm just gonna double check first. So just use the const of this tuple. That. I don't think I need to use pconst. I think I can use the regular one. Yeah. Okay. Yeah, so you take an S and then you return a new state that's just unit and that same state. So I guess we put unit in the resulting value here because there is no resulting value. Like I guess we're just trying to. Yeah, I guess one thing that's hard is like I don't really have a. I feel like I would benefit from like if this module started with a working like toy example of like here's where you might use a state thing, because right now I feel like I'm just following type holes and getting it to compile and pass the test, but I don't really understand why I would do this, like why I would use put. I know I will. I mean, definitely will. We will use it later. Commander Thrashton says, nah, not really, but I'm not sure which part of my rambling you were talking about. Nah, not really. Implement the functor instance for state S. So remember, functors, a data constructor, or you build functors with, I'm going to butcher this. You build functors with things that take one type parameter. So like list is a functor, but list of ints is not a functor. So state, because state is parameterized by two type params, we pass the state s into the instance functor rather than just state, or rather than state sa. So Thrashton said, oh, if it compiles and it works, that's not really true. Feels like an urban legend. I wouldn't support this type of advertising. I think Haskell shouldn't, but it does catch some stuff. Okay. Yeah, so maybe that's more true like when we're doing these kind of simple exercises. I don't know if they're simple, but they don't feel simple to me. Okay. Functor instance. So I'm going to take some function and a state of SA, which I'm just going to call SSA for the moment. And this should return a state SB. One second. Excuse me one moment. Okay. Apologies. Yeah. Let's see. Okay, so yeah, back to the state. So functor instance for state. So to do needs to be a state SB, and can construct the state like this. So I'm gonna kind of just follow this for a moment. How about, I'm interested, what do other people in chat think? Do you feel like in your experience, if it compiles, it works? Is that false advertising from the Haskell community? Is Thrashton coming in with a spicy hot take, or is that just or more experienced Haskellers would agree with that? I'm curious to know. What do you think, Nathaniel? You've been a Haskell for 20 years. Thrashton says I've heard that from actual Haskellers. Okay. Bona fide actual Haskellers have said that, so must be true. So I'm going to just throw in this state constructor. Yeah, the advertising should be honest. Yeah, I agree with you. Just yanking your chain a little bit. So we need to return this tuple of BS. BS. So we have an S. We have an S of type S. But we need a B. We don't have a B. We have an F that would take an A and give us a B. We don't have an A. We have an A that's buried in this SSA thing. So let us run the state. Let us run the state. Run state SSA in this thing. I'm going to call that. Should I call that? I'm going to call this Thrashton. Let Thrashton equal the result of running state on this. So this should be a function that takes an S and gives us back like an AS, I think. Let's try it. Yeah, so Thrashton is of type S to AS. And we need a BS. So I need this A. So Thrashton, I'm sorry you're going away. I'm going to say A. S. Yeah. No, I'm going to call this, I guess I call this S prime. No, but this takes an S. I can't do that. So Thrashton stays for the moment. So this takes an S. Nathaniel says, I agree with Commander Thrashton. Within Lisp, Thrashton says, within the Lisp community, there's a lot of shit like this. Language with magical powers. Nathaniel says, there's a set of problems where it's true. If the types work, it just works. But business logic doesn't work like that. Yeah. Yeah, that's true. But I would also say, like, I mean, I didn't coin this phrase, but I heard someone say, like, if you're doing production Rails stuff, like, go check your like Rollbar or your Datadog or your whatever your metrics provider, and like look what the top errors are, and they're all like undefined, property X of nil, and they're all basically null pointer errors. I mean that's an exaggeration for sure, but I mean there are a lot of those. And it does feel like it feels like our tools should be better. Like as a software engineer, I don't know. I don't want to like. Yeah, I think there's enough spicy hot takes up there. You guys don't need all mine. You find people. Let's see. Yeah, so if we run state on SSA, we get this function S to AS. We need this A, and we have an S, so we provide an S to Thrashton. Thrashton will chomp this S and give us back an AS. I'm sorry. I'm gonna remove you because that was fun for the moment. But so if I provide an S, but I don't have an S in scope here, it has to be inside this. So I think I need to say XS. Hotkey problems. So the result of calling X passing an S to X should return us that tuple, right? Should return us this. So Y should be a tuple AS. Man, this is getting tricky. This is definitely getting tricky. Y is a tuple AS. We need to return a BS. So we have this F that takes an A and returns a B. So we still haven't dug all the way down and grabbed this A. So I think if I just pattern match, I will call this S prime. I'm just going to run this again. So, aha, now I have this A, and I can pass it to this F, which will give me a B. Oh, that's a lot of work for that B. So this is a B. So this might be ugly, but I'm just, so I'm from this inner lambda here, I'm going to return a tuple. And the first element of the tuple is F applied to A, which I might not need to wrap like that, but I'm going to for the moment. And an S. The problem is which S, right? S prime is of type S and S is of type S. So let's think about this for a second from the perspective of a functor. So what do we know about functors? We know that functors are supposed to follow these functor laws. That law of identity, ID f map to x should return x. And the law of composition. F composed with G f mapped onto x is the same as f mapped onto G f mapped to x. So if I f map ID onto this, I would expect to get the same value back. Does that help me? So if f was ID, is that true though? For state? If this f was ID, then because I'm feeling like I should return s prime here. Maybe it does. Does that break the law of identity though? I'm confused. Pete says maybe you want another let in block. Yeah, I think you might be right, but I also was in a state of flow and I didn't want to break that. Let's see. Oh shoot, that compiles. Okay, so this goes back to our conversation. It compiles, but does it work? Let's follow up on the conversation. Committed or thrashed in. If it compiles, then it doesn't have type errors in places where it's total, which makes sense. But other than that, no guarantee. Nathaniel says there's a reason the two most popular dynamically typed languages today have typed support alternatives. Python and JS. So you have PEP 484 and TypeScript. Yeah. So yeah, I guess my take on that is at a certain scale, dynamic languages are just have a lower learning curve. I mean, I don't think you can deny that. But but how do you define that, right? It's a lower learning curve to get to somewhere to be able to produce something of value to a customer. Maybe we could define it that way. It's a lower learning, it's a flatter learning curve in like JavaScript, say, to build something that does something fun, for instance, or that even that, you know, you can be a junior dev with JavaScript and make good money doing stuff of value. But what if you defined what if we just said the end of the learning curve is producing correct, reliable enterprise software? Then I don't know if the learning curve for JavaScript is really flatter than for Haskell. I think it might be flatter for Haskell. I don't know if what I said just made sense, but I feel like, I mean, for example, I mentioned this a bunch, like in previous streams, because I think it's motivating, because you just feel like, what the heck are we talking about all this stuff for? Why is this even useful? What inspired me to do this stream was when I finished this exercise, I made a JSON parser in Haskell, and that just blew my mind because I'm like a beginner Haskeller. I cannot imagine making a JSON parser in JavaScript. Maybe that's because I'm just like a new programmer, but I would not be confident that it works correctly. But after doing this, like, I was very confident that it worked, and I tested it. I gave it a bunch of examples and ran it, and it worked. I was like, wow, that's amazing. So the learning curve to getting to like working reliable JSON parser, maybe Haskell is flatter. I mean, it takes years of experience to write reliable JavaScript, and even then it's like it's still hard. So I mean, you opt in for stuff like TypeScript. So Nathaniel says, as your code base increases in size, the type errors start to creep in. Types help you avoid waiting till runtime to figure out that you made a mistake. Yeah, absolutely. Don't you get JSON parse for free in JS? Yeah, you do. But my point is, like, I guess my point is, the reason that the most popular languages are like JavaScript and Python is because they're just easy to get started with. So you're gonna have more beginners in those languages, more people learning them. And I think that's good. I mean, I think there should be those languages. I love JavaScript. As wacky of a language it is sometimes, I really like JavaScript. I like TypeScript, but I guess what I'm saying is, what am I saying? Just the ability, if you're trying to get from point A to point B as a programmer learning, to get from nothing to like producing reliable enterprise software. Like, I'm wondering, how hard is that to do with JavaScript? Like, it's pretty hard. I mean, maybe people disagree with me. I'm interested to hear people's opinions. What does everyone think of that? I mean, I'm not a professional Haskell dev, so I can't say, but I mean, I guess that's why I'm curious to explore it, because it feels like there's so much power in it, and that it could be. I mean, it feels like there's a reason programming is moving towards types, like TypeScript and PEP. Anyways, I'll digress. So, functor instance for state. We got this to pass, right? We got it to compile. So let's test functor test. Passed. Okay, so debate is over. If it compiles, it works. Debate over. No, I'm kidding. So, okay, I said I would challenge myself to not just go straight to HLint. So, yeah, it's telling me I don't need this S. Let's remove the S. But then I need to compose it with X rather than. Okay, that worked. So then, okay, what is it going to tell me here? Oh, I bet there's some like fancy function that takes a tuple and applies. There's probably a function that takes a function and a tuple and applies the function to the first element of the tuple. Let's see. Haha, yeah. So use first data by functor first f. So it takes a tuple. Yeah, it does this exact thing. Cool. So by first control arrow. I've heard of arrows, but I don't know what they are. Is this the right thing though? I don't think that's the right thing. I don't think I want to use. Is this the right one? I don't know that I want to like. I mean, maybe I'll use it. My hesitation is because data by functor. Do I just do that? Is that how that works? My hesitation is basically I'm committing this code and like pushing it to GitHub, and I would like for it to be like, if other beginners follow this someday, I'd like for it to be readable, or like as not confusing as possible. So it's saying to say first F. Let's undo. See, first F. That's pretty slick though. I like that a lot. Like, it's pretty cool that you can do something so terse. Why? Ambiguous occurrence. Oh, so I guess I need to do like as B, and then say, oops, jumped way too far. B dot first, and then I can remove these. Okay, cool. Passes. Astro says no need to import, but the first in base is this like, or the first that's in scope is not the right thing, if I'm understanding this correctly. But if I do like I of B first, yeah, I think I have to do like data by functor. Whatever, I think you get what I mean. Pete says, yeah, that's the right one. Fmap is on the right, too much rust. Fmap on tuple. Control arrow first. That's the right one. Oh, my mouth is dry. Well, that's taking forever. Oh, that's not a that's not a URL. Control arrow first. Oh, that's bright. Oh, blinding me. Yeah, I don't know. I don't understand that. I think I'm just going to move on because this seems to work. Should I not? Substitute B. Substitute B for arrow. I'm not sure I'm following you, Pete. Arrow B. Oh, that's not important. Okay, yeah. I guess I don't want to get too in the weeds in case people like use this later. So X, I think I'm going to reduce this let expression though and say X test. Yeah, passes. Okay, so let me think through this. So, wow, that took a while. So the functor instance for state. We take this state record. I don't know what to call a value of this type. A state thing. We fmap this function over it, which basically runs this state and then applies f to this a value in. Yeah, okay. So then is this, so we don't update the state then? Let's run this in the terminal. So this would be our like SSA, and +1 is our F. But then, why is that a function? So if 3 is the S, then this becomes 6. And then you fmap 1 to it. Okay, so state takes, so a state thing, right? It takes the seed and then it produces some new state. Ah, interesting. And then we're f-mapping this function on this value. Yeah, this is very weird to me. Like, I'm struggling to understand why this is useful. I guess because you can like have this like a stateful value in here. Astaroth says the state is updated when you run it. You just update the return value with first. Okay. So, but why is this useful? I guess because we have this stateful variable in here. Let's do applicative. Yeah, I'd love for chat to take a stab at trying to explain why is that useful. I think that would be really helpful. I hope that's not too demanding. If not, if it is, then just don't do it. Okay. Run state. So applicative. So we need an instance of pure for applicative, an implementation of pure, and an implementation of apply. So pure should take an A and just, wouldn't this just be like this put function we made? No. Which one was it? Is it put? No, because put returns type unit there. Eval. Okay, so it takes an A, and we can create a state by doing this. This needs to be a tuple. Use this one. Okay. Yeah, so I need to return an AS. I have an A and I have an S. I get the feeling that I've done this before, though. Okay. Test pure test? No. Maybe a test apply applicative test. Okay, so the test for pure passed. Okay, Astaroth says probably more useful with apply bind, but fmap should follow the rules. Okay, so maybe we'll see the usefulness come out of this state type once we do applicative and monad. Let's see. So then, okay, so pure passed. So taking an A and putting it in a state, I feel like, shouldn't one of these functions do that for us? So put S puts it here. Yeah, whatever. Pure A. Ooh, so it says why not use tuple sections? Let's poll chat. Are you a fan of tuple sections? Should I do this language pragma? Or shall I leave it as is? Maybe I'll demo this. So if I did this, hlint will put it in the order that it decides that these should be in, which feels very arbitrary to me, but sure. And then I can say, why not this thing? I probably just need one set of brackets there. Okay, Astaroth says yes, that this looks cute. So I'm going to do it, unless someone else can convince me otherwise. Wait, you think Astaroth says that the tuple constructor is ugly? How dare you? How dare you? No, yeah, this feels intuitive to me. Like, it's going to take some value and put it there. Sure. So then we need to do apply, which takes, I'm going to call this an SSF, because it takes an S and some function, and then an SSA. And then we need to return a new state. So I'm just going to say S to do. What about others? Do you like tuple sections or no? Okay, let's see, to do. What to do? So we need to return a BS. We have an S. Okay, so this is getting interesting. So there's this function that's kind of buried inside the state type. And we need this function, and then we also need this A that's buried in this state type. And then we apply this function to this A and we get a B, and then we can make our BS. Okay. And I would do like a let in or a where, but I think it has to be inside here for S to be in scope, because we're going to need to use S a lot. So maybe what I'll do is like a let in to do here, and then hopefully my Haskell formatter will be nice to me, and I'm going to just say x equals 1 and just see. Okay, yeah. So that's kind of ugly, but I'm just going to roll with that. So hopefully once we have it implemented, we can unwind it to something more readable. So let's first, this is interesting, because running the state on this is probably going to change the value of the S. So if I do run state on SSF, and then I pass an S to that, then now I should get a tuple. This tuple should be my F and some new state, right? So now I've like accessed this. Can I just use get? No. Eval. So if I do eval, that will give me the A. But I have a feeling I'm going to need this S prime, because immediately what I run into is, okay, I have this F, but I have this F takes an A, but I have no A. I need to get this A. So then I can say like run state on SSA, but I immediately run into this. Do I give it S or do I give it S prime? I think I should give it S prime. That's an interesting question. I'm going to say I'm going to put a note to remind myself. So this should be a S double prime, because this is also going to update the state. And then, interesting. So now, okay, so now this is all inside of this state constructor. I was about to just do another state constructor here to build this, but I'm already inside of it. So now I need to return, I think my to-do is a type BS, whoops. To do BS. I have all these S's. And I can get this B now because I have an F and I have an A. So if I do F applied to A, and then that's inside this tuple. So which S do I use? I think I need to use S double prime, because my intuition is I should probably use each of them once. Because I mean, I could just ignore these and just use regular S every time. And maybe we should try that in a second. But first I'm going to test this. Test applicative test. Aha. Works. Can someone in chat explain to me this? So with state, I mean, I feel like I'm kind of having to think in an imperative way with this. So run state. Okay, pure +1 applied to pure 0. So pure will give us a new state. So we can do a stateful function and a stateful int and apply those, and we get, apply those to 0. We get 1, 0. Oh, because we're adding 1. So does pure takes an A? Oh, pure also takes an S. See, that's confusing because state, because this is a function. Remember, because we changed this from S to AS. So maybe we should. I don't know. Let's see if that works. Yeah, that doesn't work. I guess I'm just trying to think through. So pure takes an A. Yeah, so if we did Pete asks, are you just wanting to refactor but have it working? Yeah, so it works. I don't necessarily want, I do want to refactor it, but at this moment I'm just trying to understand why, like what this does and why. So run state. So maybe this would help if I put, let's put a 3 here instead of a 0. Okay, this is helping me because it's like the 3 ends up here. So the 1 is being added to this. So pure 0 is this A, and then this highlighted expression takes some S and evaluates to an AS. And then this expression, highlighted expression, takes some S and returns an S plus 1. Returns yeah. So running the state, so it takes a 3. I guess maybe I should try, like, does this work? Okay. Okay, so then this is a function. So this 3 just get put in, let's just try 1 here. Okay. Yeah, so run state, it's just grabbing this value and putting it in place of the S. Yeah, I don't know. I'm kind of struggling with this. Yeah, this is super hard to read. So we have a state here which has a 7 and then appends some list to banana. And then this one has a +3 and appends something to apple. And then we apply this one to this one and pass it a nil. Oh wow. So we get the +3 gets applied to the 7, and then this nil gets appended to apple, which gets appended to banana. Wow. Okay, so then this is sort of like a stateful. Maybe that's why it's more useful, is like you can build up some state in this side. You're doing your typical like process in here, and then you're having some effectful like result in here. I'm gonna push on. So, but maybe what I should try first is like, what happens if instead of getting this F out using S, we get the A out? So then like maybe it'll be more clear if I just do it. So so I'm going to pass S to this, and then this will return my S prime, and then I'll pass S prime into here, and this returns my S double prime. See what I'm doing? So I'm just gonna, I get them in this order, but I'm just going to run the state on this one first. I imagine that this particular example would be like banana apple instead of apple banana. Let's see. That compiles. So let's do test applicative test. Okay, expected 10 apple banana, but got 10 banana apple. There you go. So that's why we have to do it in that order, I suppose. Is that just part of... Would this be a valid implementation of apply though? Like, does this actually break any of the rules, the applicative laws? Does anyone know? So yeah, I'm not going to go through and try to test all of these laws on state because that just sounds really hard. But that does sound like an interesting question. So I'm going to roll this back to a version that does work. R test applicative. I'm going to, yeah, I'll do it. Astra said that he thought this was cute, so we'll leave it. Okay, don't need these brackets. Okay, so yeah, maybe I shouldn't unwrap this. Maybe I just like chat. Would you refactor this? I don't know that I should like. I don't know how I can make this written more clearly than this. Maybe we'll see what Tony does in his in the exercise solutions. That'll be interesting. Okay, so let's look at monad. The monad instance for state S. Okay, we're getting into some real nitty gritty here. State is already hard for me to understand, and monad's hard for me to understand, and now we're just going to smash both of them together like an apple banana smoothie. So I have some F that takes an A and returns a state. I have this SSA thing, and I need to return in state SB. So I take some S and I return something. Chat is very quiet. Is that because this is boring because you already know how all of this works, or because you don't know the answer, or because some other reason? Maybe perhaps your dog is also licks your foot from time to time. Okay. So I need to return a, whoops. I need to return a BS like usual. How can I get a B? Well, from this F function. But how do I do that? I need some A to pass to the F function, and that's buried in here. So I think I'm going to take a page out of this, my applicative instance, and say, Astra says, it's 5 a.m. and insomnia sucks, even if this is kind of nice. Dang, 5 a.m. Let's find out where Astroth is. Time zones. Is Astroth in Algiers, perhaps? I was hoping to get like a world map with all the different time zones. Let me see. I'm in GMT +6, and it's 10. So GMT would be oh wow. I'm just blanking. So it would be like 4 a.m. So then GMT -1. I'm getting super distracted from stream. Bit further north. Yeah, Astroth, where are you? I'm curious. Okay, so so you must be in GMT -2. GMT -2. That's not what I wanted. GMT +1. Oh, was I off? Oh, okay. I'm in Sweden. Oh, okay. Cool. Swedish viewers of the stream. It's awesome. Internet is awesome. Okay. Well, I'm sorry you have insomnia. I hope I'm not enabling your insomnia. Hope you get some rest. Okay, so let's go on here. Yeah, so I said I have this F that takes an A that returns a state with B in it, and I have this SSA. So yeah, okay. So I'm gonna do let this thing equals run state on SSA, and I'm gonna give it S. So I'm basically following this pattern here, and I should get an A and an S prime out of it. So now I have this A, which I can pass to this F. So if I pass an A to the F, then that should give me back this. So this is a state, and I could run state on FA, and then I'm going to use this S prime because it feels like the right thing to do. I don't actually know if that's true. And then that should give me back a BS double prime. And then I need to return this. Oh, actually, can I just... No, FA returns a state SB, so I don't need to run this, right? Do I just return... Do I just return FA here? Why is this mad at me? Couldn't match expected type BS with actual type state SB. Okay, I need to return just the BS because I'm inside the state already. But can I like flatten this? I haven't implemented join yet for state. Ooh, this is tricky. I might need some help here. So I think what's happening is I'm actually returning, Astroth says, you were on the right track before. which track was that? Basically running this state. Okay. So let me go back to that. So to do, yeah, thank you. That was the jog that I needed, I think. So I should get back a BS double prime from running run state on the result of FA and S prime. Okay, so this is starting to look like this apply. So we run the state on this value, and then we run this state on the result of calling F on A. So this is what we get back when we apply F onto A, and then we run state on this using S prime, and then we get this S double prime, and then we need to return this, perhaps? Banana Puddin', welcome to the stream. Banana Puddin' says, Banana Puddin' 9, excuse me, says, uh-oh, I see monad. Yes. Oh, man. That definitely brought some much needed levity into the situation. Thank you for joining, Banana Puddin'. And that's you're timely as well, because this last example had apple and banana. That's amazing. Maybe we should try this. Run state, and then I'm gonna try to add and apply here that like appends puddin' to this. This is weirdly actually exercising my recently acquired knowledge of state. So then if I apply this to a state, except this 7 needs to be like a times 2 now, perhaps. And then I can make this a S to a 3, let's say 3. Oh, it's hard to read. S appended to puddin'. This is totally not going to work. Oh, I'm so close though. I can almost taste the apple banana pudding. State S. No, okay. Well, maybe I'll have to give up on this, but state. Maybe the Haskell formatter will help me. No, I give up. Sorry. No, what I could do is I could change apple to banana. And I can change banana to puddin'. Banana puddin' says no worries. No. Oh no, what did I do? Okay, well. Let's see. Let me get to a state that compiles. Okay. Yeah, there you go. Yay! Okay. Banana pudding. Okay. There we go. That's all I needed. So how do we implement apply for state? Wait, does this work? Oh, yeah, that was apply. What about monad? Test monad test. Oh shoot, let's go. Just implemented monad instance for state, the implications of which are somewhat lost on me. But I think we're about to see here in this find m. So Banana Puddin', what is your experience with Haskell? Did you just come across the stream, or are you interested in Haskell? I ask all the newcomers to the stream. Okay, so we have monad now. I think I can just, this is a bit redundant, right? So I can just say this. So I can get the A from running state on this SSA. And then I can apply F to the A. Banana Puddin' says, I'm a uni student. I've used some functional languages for a couple of courses, though not Haskell. Okay, cool. Well, welcome to the stream. Mostly know of monads from a friend who is really into PL. What's PL? Did you mean ML? I do not have any useful insights into them, though. Well, PL theory. Oh, programming language theory. Oh, okay. Gotcha. Yeah, so a few streams ago we talked about monads, and if I would recommend this course to understand them, because I read lots of articles, and things trying to explain monads via like analogy and examples, but then I did this course and you get to monad and you're just like, oh, I see. You don't have like an amazing intuition for it right off the bat, but I mean, you stare at this type signature long enough and do enough exercises that you start to get a feeling for what they are. Yeah, we had, there's a bit in one of the streams where we went over how this F map is, you take a value, you take a function, that goes from like A to B, and then you take a value in some context. This is actually good. It's always good for me to have to re-explain things. So, and then the chat can correct me where I'm inconsistent or where I'm wrong. So fmap has the signature where you take a function and then some value in a context. So k here could be like list, for instance, and then fmap is applying this function inside of this context. So then you get a b and still inside this k context. So we can demonstrate that with like map on lists, basically. So we can say fmap +1 on some list, like 1, 2, 0. We get 2, 3. We could also fmap +1 onto like a full 1. So the type of full 1 is this optional type that we made in an earlier module. So fmap has this feeling of like applying a function to a value in some context. And then this apply thing is like the function is also in the same context. So that's weird because it's like not that intuitive for like lists. So that's like you could have a list of function and a list, and you apply each function in this list to the list. But maybe a better example is like a full +1 applied to a full 1 should give us a full 2. So why I think this might be helpful is like, what if you were trying to do some stateful thing, like there was a network call or a database call or something in order to get this first function, and it might fail, right? So you might get an empty, and then you apply that to some value like a full 1, and you just get an empty because the first one didn't work. So then we get to bind, which is kind of like how you implement a monad, and it has this signature. So rather than function, applied to some value in a context, or a function inside of a context, the function like lifts this value into a context. So it has this feeling of like you have it has this sense of flattening, right? Because you have this value, this KA. So this could be a list. So the A could be kind of like values in a list. And then you're going to apply this function to each one. But then this function lifts that value into a context. So if K is a list, and then you bind this, value onto this function, then you're going to get a list of lists, because each A is going to be lifted into this KB. And that would leave you with like a KKB, but you just want a single KB. So the instance, the monad instance for list is flat map, because like this example is maybe instructive. So we have this 1, 2, 3 list, and we have this function which takes a single value in and returns a list. So it just this function just like pins a value to itself. So if we were just to apply this, if we were just to f map this, for instance, function onto this list, then we get this list of lists. So if we use this function from A to KB, but we f map it onto a KA, then we are going to get a KKB. So we'll get like a list of lists. But if we use bind instead, then we get just a single list. Anyways. So there you go. That's what a monad is. I don't know if that was helpful at all. But thank you for listening to me explain it. Maybe that will be helpful to someone out there. Let me refresh myself where I'm at with state. A lot of failing tests still. So we had monad passing, and then we have to do this find m thing. Yeah, banana pudding. If you have any questions or clarifying questions about that, or anything else, let me know, or ask chat. They're probably smarter than me. So find m. Let's read what. Find the first element in a list that satisfies a given predicate. It is possible that no element is found, hence an optional result. However, while performing the search, we sequence some monad effect through. Note the similarity of the type signature to list find, where the effect appears in every return position. List find. So list find looks like this. And find m. So the effect appears in every return position. So it's an f bool instead of a bool, and an f optional a instead of an optional a. Is findM like a useful function in vanilla Haskell? Is it called findM or is it called something else? Does anyone know? Oh, I also want to call out Swarm Collective followed me 3 minutes ago. I really appreciate that, Swarm Collective. And if anyone in the chat hasn't thought to do it, wants to follow and hasn't thought to do it yet, please give me a follow. I'm almost to 50 followers, which would make me a Twitch associate, which I don't know what that means, but sounds cool. But yeah, appreciate that. Astaroth followed me 9 hours ago. Thank you, my friend. Banana Pudding, thank you for the follow. Swarm Collective says, always like seeing more Haskell. Awesome. Yeah. Oh yeah, I should do a shout out. So tomorrow, I usually stream Monday, Wednesday, Saturday, but tomorrow, me and my buddy Pete, who is better known perhaps to you as PFMRF, Puff Murph, Pete Murphy. I think that's your last name. Yeah, tomorrow me and Pete are going to stream together. We're going to do like a pair programming thing. Pete has been going through a PureScript course on his stream. And it has a lot of similarities to this. And I believe Pete is, are you going through in your PureScript course? It's, you've just been going through like stateful stuff, I think. I don't know if Pete's still in the stream, but yeah, so join us tomorrow if you want to hang out. Maybe we'll do this the state T module tomorrow. That would be fun. Okay, but in the meantime, we are going to implement this findM. Yeah, so Swarm Collective. So PFMRF, is that Pete's channel? Yes, it is. Heck yeah. Maybe I should link it, or I can click his name. Oh man, Twitch being slow. Yeah, anyways, I was going to try to drop a link to Pete's stream, but maybe you can just click his username. When I click your name, it just like goes to chat history. Okay, so yeah, feel free to drop a link to your stream, Pete. So findM, I'm kind of lost on this, so I'm just gonna start like with typed holds like I always do. So we have this function and we have a list A, so I'm just gonna say F and A's, and then to do, and then yeah, my dream is that we start a mob programming, a Haskell mob programming collective, a swarm collective, if you will. And we just like mob program Haskell together in a giant like clubhouse style room. That would be really fun. It might be chaos to do. So I need to return an F optional A. Swarm collective, that's exactly where my name comes from. Well, awesome. Let's do that. Maybe we could like that was kind of joking, but I was also kind of serious. I think it'd be really fun to get a group and I mean maybe do like plan some weekend and then find some like open source Haskell thing and just do like a spike and see if we can like tackle like a couple issues for some open source Haskell thing and just stream it. That would be super fun. It'd probably have to be someone a lot more capable than me to lead it, but I would love to shadow or pair program, do something like that. Man, that would be like such a good way to learn too. I don't know why that's not already a thing. Like maybe we need maybe we need to build our own Twitch platform, but just for programmers that want to like mob program together. That would be really cool. Maybe bring an unmaintained library up to current GHC. That's a great idea. I don't know that I'm capable of doing that, but if that's something you feel confident doing, that would be sweet. We could I'd definitely be down for that. Yeah, send me a whisper or something. Maybe we can get connected. Okay, let's do find M. So we have this F that takes an A and returns an F bool and a list of A's. And what is my to do? I need to return an F optional A. So let's see. I have this list. I know that I'm going to need to go through this list and start checking them. I mean, I have this predicate. I'm going to call this a P for predicate. Yeah, so for each element in this list, I'm going to call the predicate on it and get back this bool, but this bool inside this F context. The first element in a list that satisfies a given predicate. It is possible that no element is found. However, while performing search, we sequence some monad. The sequence word is making me think that we need to use the sequence function. We sequence some monad effect through. Let's see. I mean, my first thought is default because it's a list. Please tell me if that's like a bad idea. So, I'm just going to throw my cons and nil hole in here, and then I'm going to add a reduce the A's. And then nil needs to be an F of optional A. And there might not be a result. It said no element. It's possible no element is found. So that would be an empty, but not just a regular empty because it's an F. So it's a pure empty. F is some monad, so we know it has pure. All monads are applicatives, and applicatives must have this pure function. So I think that's my nil case. So then my cons should be a function that takes an A and this F optional A. Am I on the right track? Swarm Collective, I'll be heading off to get some sleep now. It's good to find your stream. Yeah, thanks for joining, Swarm Collective. Thanks for the follow, and yeah, hope to see you again. Cons. Let's check the title. What does title say? Yeah, cons is a function that takes an A and an F optional A. So let's suppose that we have those. FOA. Someone stop me if I'm heading off a cliff here. Yeah, so I need to return an F optional A. So state's going to come in here at some point. Maybe F is a state. So at some point I'm going to need to start checking these values with the predicate. No. Don't do that. So my intuition tells me to do let FB for F of bool equal P applied to A. So A is some element of the list. And then we get this F bool back by applying the predicate to it. We need to check this bool. The first element in the list. So I'm just going to play around here for a second. So get the formatting working. So I'm going to say result is, I have this FB. I need to check if it's true or false. It's a monad because we have this type constraint, monad F. So I know I can bind it. So if I bind it, then I'm left with a B for a Boolean. And then if B is true, then I want to do something. If it's not, I want to do something else. If B is true, then I want to return this element that matches the predicate. So I need to return it in this an optional. Maybe I'm going to put this in place of to do. And I'm going to say to do one. Am I on the right track at all here? Does anyone know? I feel like I'm making progress. So to do one, F optional A. So if this was, so this is where B is true. Astros is looking good. Okay, thank you for the encouragement. FB. So yeah, so to do one is the case where B was true. Then I think I want to return a full B, but it needs to be in some F context. So maybe I shouldn't bind, but I should apply. So if FB is an F bool, and then if I F map some function, then I'll be left with an F of whatever the result of that function is. So then I apply this lambda to the F of bool, and then if B, I return a full B, and then I'm thinking this would be an F optional A, but Astra says stick to bind. Okay. Okay, I'll stick to bind then. So then I need to return. So full in that case. Oh, you're right. B is Astros is B is the bool, not the value. Thank you for that. So, yeah, I'm saying if B, then we have this element A. So full A. Wow, HLN is very mad. Probably because this is not an F optional A, but just an optional A. So then maybe it needs to be a state. We haven't used state yet. And we know we need to like sequence this monad effect. And we've seen from like apply, we kind of do this sequencing where we have some state and then a S prime and then S double prime. And we've seen bind does that kind of thing too. Yeah, so I'm going to say the result, given that we're in the state module, that we need to return. Let me sit up. We need to return like a state S. This will type check now because it's an F of optional A where state is F. Else we haven't used this yet. Okay, so pure. So if we're saying state is the F, then this pure empty, this pure is going to put empty into this state. So if we look back at pure, so if that's empty, so then that means this FOA is a state, which we'll probably need to run. So let me see if I can wrap this. Else, oops. I don't know why the. Let me just say pure empty here for a sec, see if it'll format for me. No, it's not formatting. I don't know why. Let's see if I do a to do and then let's see if the whole looks like it makes sense. Parse error. Okay, that was what I was afraid of. Do I not have enough parens? Ah, that's why. Always with the parens. Okay, there we go. So then I'm gonna use the regular bind instead of left bind. Because that, I don't know, feels more readable to me. This is getting like a really crazy looking, like wonky looking function. Let's see. Okay, so yeah, where was I? FOA is a state. So I think I want to do run state FOA. But I need to pass this some s. So let me think through this. So we've checked the first element of the list, and that yielded the stateful Boolean thing. Then we bind this stateful Boolean. I can't use run. I guess I can't use run on this. Yeah, that's what I was just getting to. So Astra said state isn't mentioned in the type declaration. Yeah, so I can't just say state here because I don't know that f is a state. So maybe I have to say pure full A. Oh my gosh. Struggling. I think that's right. I'm just confused about where state comes in. So this should type check, but I am not confident that works at all. It passes. The heck? Does that work? Is it because the bind is like doing the sequencing for us? What? Okay, so the test says find C and AH. That works. My mind's kind of blown right now. Find him. Let me try to stare at these examples and see what I can glean. Okay, so this is saying let px equal this function that takes an s. Banana Pudding says it's been a long time since I've tried to think functionally. Yeah. Yeah, it's definitely a huge paradigm shift. Like especially there's some days like because I mean I'm working in like Rails and TypeScript like React every day, and then switching that from to stream sometimes is like pretty rough. I've been writing Banana Pudding says I've been writing tons of C. It's like the exact opposite. Yeah. It's very different way of thinking. Pure. So pure x equals C. So this is like our predicate, right? So we have this function const with pure x equals C. Where's this x coming? Oh. So P is this predicate that takes an x and it checks if x is equal to c. And it calls const on that. And then that's bound, put 1 plus s, get what? In run state find mp. List h is this helper function so that you can write. So basically we have this list of letters like A to H. And then we're running find m on this list with P as our predicate. I'm going to wrap these back. I think I'm starting to get this. So yeah, okay, so I'm starting to get this. So we have this list A through H. And we have this starting value 0. And this predicate get, so this get function, if we go back up, get returns a state. And state, like you can do run state get 0, and then you get this, the initial state, right? So you bind the result of get, which would sequence we'd run the state in. Okay. Let me continue with my first train of thought. So we have this list of letters A through H, and we have the starting value 0. And then this predicate P takes an S that's the result of this state. Put 1 plus S. So we get some initial state, and we use put to put this function. So let's go back up to put. Put takes an S and returns a state S of the unit. So you can do run state, put 1, 0. And then there's no value, but there's this initial state of whatever you put there. So we're putting a function there. 1 plus S. But then this predicate basically takes some value, and the result okay. So it produces a new state. So we're going to start out with this, and then the result here is going to be the Boolean, but then it's going to, each time it's going to produce a new state and like add 1 to it each time. That's what I'm trying to say. So this predicate checks for the letter C, but then it's also adding 1 each time. So that's why the result is full C3. Because we checked A and we added 1, and we checked B and we added 1, so that's 2, and then we checked C and we added 1, so we get 3 here as the state, but then the value is full C. Anyway, sorry, yeah, I'm sure many of you were like, yeah, I got that. But that's kind of mind-blowing to me. And it's also starting to like become more clear to me why something like this would be useful, because now we have a purely functional way of, I mean, that's the whole point of this module, right? It's like we have this purely functional way of like what's the word I'm looking for? Not like mimicking state, but like we've implemented implemented like a stateful value in the purely functional way. So we could like count how many values we checked. I mean, that's very useful. Wow. So find m. That's cool. So your predicate can basically say, this is the condition I'm looking for, and then this is the stateful like effect I want you to do every time you check a value. Wow, that's cool. Huh. Anyway, sorry, I'm yeah, maybe that's only cool to me, but let's try to refactor this a little bit. So this FB, I think we can just turn into don't really need that FB thing. Let's try to wrap this up a little bit. Oh. Test, find m, test. Yeah, it passes. Okay. Find I. So if we do find I, yeah, so the result is empty 8 because I does not exist in the letters A through H, but it checked all 8 values. And that's why this results in empty. But then if we said, rather than checking for I, we said check for H, then the result should be full H7, full H8. Yeah, because it's the 8th value. So let's check for F. I mean, yeah, 6. Okay. Is anyone just completely lost? I did my best to try to explain what I think this is going on. If someone feels like that explained it, then a thumbs up maybe. And if like you're totally lost and you have no idea what this does, thumbs down or question mark or something. Happy to chat more about it. I mean, personally, I think this is really powerful and instructive. Like at the beginning of this module, for those that have been hanging with me the whole time, wow, thank you for one. But like I was asking a lot, like I don't get this, I don't get why this is useful, and just kind of implementing these functions. It's the whole like wax on, wax off Karate Kid thing. It's like, why am I doing this? And then you get down to this find m, and it's like light bulb moment, because now I have this stateful value here. Okay. Chat is quiet, so I'm gonna persist. Pete says, has this course introduced do notation? No, it has not. Not yet. Would this be much easier to read in do notation, perhaps? Is that what you're getting at? Not necessarily. Okay. First repeat. Find the first element in a, what makes you think of do notation, Pete? Is there something relevant there? First repeat. Find the first element in a list that repeats. It is possible that no element repeats, hence an optional result. Okay, so we have to use find m and state. Okay, and with a data set. So we haven't actually used set before. Different. Pete says different pedagogical approaches. Yeah. Yeah, I think it's just trying to let you understand like what's under the hood. So we have an ordinal a list of them, and we need to find the first element in this list that repeats twice. We need to use this findM function, and we need to use state, and we need to use a set. So I suppose what we're going to do is we're going to loop over this list. We're going to have a set of all of the values we've seen so far, and then each time we check a element of this list, we check if we have it in this set yet. And if it does, we return full of that value. And if it's not in the list, then we return empty. So first repeat takes a list. So I'm just gonna add a reduce and do fold right cons empty. So my nil case is just empty. That should satisfy this, and cons should take an A and this optional A. Let's start there for a sec. A and an optional A. So we need to use state. So at some point in this function, we need to add A to our set. We also need to check. We need to check if. Okay, so we need to check if A is in the set. Astros says, doesn't findM already do that part? Perhaps it does. So you're saying findM. There's no notion of a set in findM. The fold, I mean. Yeah, you're right. You're right. So what I should be thinking instead is findM. Thank you for that. I would have spent a lot of time implementing fold again. So findM should take a predicate in our list A's. Which we can add a reduce. So I'm just going to remove that. And then I'm going to say where P equals. And I guess P is what we need to. findM returns an F optional A. We need an optional A. So I guess now that we're using findM, we get to dictate what the F is. So we want it to be state. Which means in order to get an optional A out of this F of optional A, maybe I need to run state. I don't know if that's right. P let's see, P Sorry, got distracted for a sec. Well, I can look at the type signature of P. Should take an A, return F bool. So I want to do like if A, then something else something. So if A, then I just want to return full A, right? But I need some condition here. So I need to check the set if A is in the set. And then where does my set come from? Comes from a stateful value. So I'm looking up at this predicate example. Yeah, I don't need an if. I need to produce a bool. So I'm just going to follow that example up there and say, supposing I have an S. Yeah, where is this set coming from? I guess I'm thinking like if I had a state S, it's going to be like this, right? If the stateful thing was a set of all the elements I'd seen before, and A is like the result of like the current, like the bool. If it's just like this one is like const pure x equals I. Man, this is really tricky. Struggling to get a foothold. Be happy to get any hints. S. Data set. Browse data set for some inspiration. So data set internal. I don't know if that's what I want to look at. I think I want to look data set set. Is it already being ported? Yeah, it's S. As Troth says, find M returns an F optional A, and you want an optional A, so you'll have to do something with the result. Yeah, I mean, I need to, okay. Oh, I see. So you're saying this isn't going to type check yet because this will do, this will return an F optional A. Okay. Yeah, so in this example, they're doing run state over the result of find M. So I actually, you know what I might do is just copy this. Hope that's not cheating too much. And then I'm going to say let that in this. But instead of list these things, I'm going to say it's our list of A's. Ah, okay. And then so we need some initial value, some S. So maybe that's where my set is. Set dot insert empty maybe. So let's figure out how to use sets. Data dot set. Port data dot set. Set dot I don't know how to create a set. Data set set. Oh, okay. So there's this empty function. What else is there? LMs. Let's look at the type of that. Okay, so elements, I'm guessing that is. So you pass a set to elements and you get a list of the elements. So if we pass an empty set to elms, okay, starting to get somewhere. Set from list. Let's try that. What from list? Yeah, okay. Yeah, I think I want to start out with an empty list. Okay. So now I'm giving an empty list as the starting state. So I'm going to run the state. Astros as empties, right? Okay. So then I think I want to do something like lms drop filter find. I'm definitely going to use insert at some point. Maybe I just need like lms. So when I do put, get returns state. What I'm going to do is throw a to do in here. Do I need, I don't think I even need this get here, do I? To do. S member. Member. Oh, okay. So then, yeah. It just says whether that, whether that's in that value's a member of the set. Yeah, exactly. Thank you. So, so we just do S member X because the predicate takes some value X. So we're checking if this is, if X is a member of some set, and S is our initial, yeah, S is our stateful value. So we say so this will be the result. So like our A in state A, state SA. So then S should be the new set with the element inserted. Let me just do this. So I don't think I would need this get here, maybe. Key. Okay, so then I think it's S insert. It takes an A and a set A. So insert X into S. Couldn't match expected type optional A with actual types tuple of optional A in set A0. And P predicate expected type is A to state. Set A bool, and it's actually a state or a set. So I guess I need to create a state like that. Okay, that solved one of the problems. So then our function here is returning a tuple when it needs to return just a value. So then we just eval this. Is eval the one that, or is it exec? Yeah, eval gives us back the A. And Astaroth is telling me that this is confusing things. So maybe that was a problem. No, maybe we just need first. Haha. Okay, that compiles. You have to work so hard for it to get it to compile. When it does, it feels so good, man. Okay, add source test loader test first repeating. First repeat. No, maybe I don't need to add loader. I need to add a test state test first test. Hey, look at that. Passes. Oh man. Wow. That was rough. Brain hurts. My brain hurts. Eval state. Oh, cool. I didn't know that was a thing. So eval state does this. Wait, we didn't do an eval state, did we? No. Eval state. Huh. Refact. Use eval state. Where does this eval state come from, though? Man, that was, wow, that was really hard. So we use findm. Run state. Findm takes a predicate and a list. Oh, it's eval state in normal Haskell. Eval here. So if I go to a regular GHCI, then eval state. Or do I need some like data type imported? Eval state Haskell. State monad. Oof. It's bright. Control monad state. ST. Oh, there it is. Control monad trans state lazy. So it takes a state and an S and returns the A. Good to know. Plus data, of course, yeah. So then, oh, right. So then I can just run eval on this instead of first. Like this. Oops, wrong terminal. Let's go to this one. Okay, yeah. So rather than doing run state and then first, we can just do eval, because that's what eval does. Astaroth says you can do Google from DuckDuckGo. No way. With bang H. What? That's so cool. Yeah, thank you for showing me that. Wow, I'm impressed. So DuckDuckGo must be like fans of Haskell that they like put that feature in. That's amazing. That is really cool. Okay. Yeah, so we got this predicate, the state. It checks if it's a member of the set, and then the new state it produces is it inserts it into the set. Okay. So then our findM function knows that this predicate is like some monadic Boolean. So it knows that it needs to bind it and then check. Wow, that's really mind-blowing. Okay, let's see if I can finish this. I don't know if I can finish this tonight. Distinct. Remove all duplicate elements in a list. Use filtering and state with data set. I'm going to remind myself where filtering comes from. We did that in applicative. Applicative filtering. It takes this looks similar to findM, except it's an applicative instead of a monad. Okay, so we have our A's, and then filtering. Let's call this P. And then we have A's where PX equals I might do it like this. Like where this. Let me make sure that still passes paranoid. Yeah. Okay, so our PX equals state S. Filtering takes a predicate, returns a k-bool, ka. Filtering greater than over this list. Apply to 8. So we want to check some Boolean and do we need to return a list? Yeah. I feel like why don't we just go through the list, add each element to the set, and then at the end we just do set from set to list or whatever. Data set. Is there there's a from list, to list. So I think the value I want to man, this is so tricky. So filtering takes this. If B, then it appends to the list, else. Yeah, so I guess what I need to do to use filtering is like build up the set, and if it's not in the set, then I append it. I mean, filtering does that for me. Otherwise, add it to the set. Sets are ordered though; it should probably return things in the original order. Ah, okay, good point. So I think in my state, this first thing needs to be the bool. So then that would just be S member XS, similar to the above. It's like, is it a member of our set? And then it's very similar, right? We add it to the sets. Does that actually work? Filtering P. Couldn't match type. So expect type list A list A. Actual type list A is state. Yeah. So then we need this state. So then instead of eval, we do exec. list A1. I'm just going to say where y equals filtering p. And then I'm going to say to do. Oh, and I need my a's back. To do should be a list A. Y is a state. But does exec takes a state and an S and returns an S. Okay. So then oh right, I need to pass it my my empty set. S.empty. Can match type list A. Lost. I'm going to go back to this y equals filtering PAs. This is to do. Okay. New list A, y is a state. So what Z is run state y set dot empty. List A. Z is that, so then need first. Okay, so it's doing the wrong one. Z. Got it. Distinct test. Failed. Okay. So expected this A through Z, but got an empty string. I'm not sure. Use filtering state. Estras says it fails when no element is duplicated and passes when all are. Distinct no repeats. Okay, so fails when no element is duplicated, passes when all are duplicated. Every element repeated. Yeah, so I have it backwards. So I'm saying so filtering, it checks the Boolean, and then if the Boolean's true, it appends it to the list to ultimately return. But I want to append it to the list if it's not repeated. Like if it's a member of the set, then I've already added it to the list. So what is the function for that? Not member. Not member. There it is. Huzzah. Okay. Oh, thank you for that. I was floundering there. Wow. Okay. Very tricky. I feel like I should be able to use exec instead of this. Or is it a val again? So val, yeah, val does what I need. I'm just kind of unwinding this refactoring. Okay. So evaluate filtering PAs with an empty set or a predicate. Takes a state and checks if takes like a set basically. It checks if the element's not in the set. Seriously. Awesome. Yeah. Makes sense. Oh my gosh, is this the last one? Okay, good, because I'm fading. A happy number. A happy number is a positive integer for the sum of its digits. Eventually reaches 1 after repetition. In contrast, a sad number, not a happy number, is where the sum of the square of its digits never reaches 1, because it results in a recurring sequence. Happy number is a positive integer where the sum of the square of its digits eventually reaches 1 after repetition. Sad numbers where the sum of the square of its digits never reaches 1, because it results in a recurring sequence. Use first repeat with produce. Yeah, first repeat and distinct are very similar, as Taroth is pointing out. The only difference is this. Yeah. Yeah, thank you for pointing that out. Yeah, makes sense. Use first repeat with produce. Use join array square function. Use library function optional contains digits int. Is happy 42. So the sum of the square of its digits. So 7 squared is 49. Oops. The sum of the square of its digits eventually reaches 1 after repetition. So 7, happy 7 is going to be 49. And then you square each of these. That's 16 and 81. 16 plus 81. Whoops. 97, right? That would be 1 plus. Am I doing this the right way? This doesn't seem like it would ever reach 1. Let's keep going. 90, that would be 130. 1 squared is 1 plus 9. Plus 0. 10. Okay. And that's 1. Okay. Then 4. 4, 16. 1 plus 36. 37. 9 plus 49. 58. 89. repeat at some point. 60. Oh man. Maybe I should be writing a function to do this for me. So Astroth, you're saying monads are fun because like how first, repeat, and distinct end up being like opposites with just a single slick switch here. It's really hard to wrap my mind around. Ugh. Let's get produce. I really want to wrap this up before I go to sleep. It is a bit mind-blowing. Yes, this is produce. So produce takes function a to a and an a, makes a list. Okay, so if we do like take 5 from produce plus 1 and 1. Okay, so produce, yeah, plus 1 and 1. Use first, repeat, produce. So I can produce a list of values. So I take some n, let x's equal produce some function. And I think what I'm going to do is this is f, and then let f equal I want to square this. And then digit to int. I think I want to show this, because if I show a number, it's a string. The sum of the square of its digits. Okay, so I think what I need to do actually is have this a bit backwards. So I need to show in first. So now in is a string, and then I'm going to fmap over that string, and for each I'm going to square, but I'm going to say digit to int. So I'm going to turn in into a string. So now it's a list of characters, and then I'm going to fmap over that list, turning each one into an integer again, but I show it so that it's a string and I can get at each digit to int, and then I square that digit, or square that integer. So now I need a square function, which it said I should use. I should use join to do a square function, which I think is just join multiply. Yeah, because we talked about this for a long time in Monad, how join over functions like uses the value twice. Parse error. So what does this give me? So this gives me like a list of squared digits. Now I need to sum them. I don't have an in, that's why. In to do. Main course is to find multiple files. So it takes an integer. Use the new Hoogle trick that you taught me. Okay. So I'm going to say bang h integer to int. So yeah, from integer. Couldn't match type empty list with list. Expected type list int, actual type list int. I think I just need to do like their each list thing. List h. Show in couldn't match type char. List char with actual type p string. Ugh. Oh, maybe I need to use this show prime. And then x's is less than. Okay, so now I've actually got, oh man, this is brutal. This is brutal. I think part of it is because I'm so tired. Let's see. Okay, so should produce an infinite list with this function. And it's changing this n, which is integer, into an int, producing this list, which basically turns the n into a string, gets its digits, squares them, and then sums that list. Yeah, Astaroth and I. Yeah, I'm sorry that you have insomnia. That sucks. So then x's should now be an infinite list that's like, maybe we should try it. Can I do this? Let's see. Let this equal that. Square is not in scope. Well, let's put it in scope. Square that, and then x's. Oh, n is not in. Let's say 4. Integer. So now if I take 5 from x's, so we square 4 and we get 16. Then we square each of its digits, so we get 1 and 36. We add those together and we get 37. So let's take like 20 of these. Aha, so then if we keep doing this process, eventually we hit a repeating digit, this 4. We hit it again here. We're doing the sequence. But if it's 7, so let's say n equals 7, and then we say x's, then we say take 20 from x's. Aha, then 7 eventually hits 1 and stays 1. Now we're making some progress. Ezra says, I'll live. Does it work if you put a 2 integer before the sum? I'm not sure I understand. Actually, I'm not sure why it has to take an integer. Because I haven't finished this yet. So then I think what I need to do now is see, use first repeat produce. So I'm going to use first repeat on x's. And that should get me an optional. But it's an infinite list, right? Yeah, but the one will end up repeating. So if the first thing that repeats is 1, then we're good. So then first repeat turns an optional. Then optional contains. Let's look at that. Optional contains. You say a value and then some optional. If the value you say is the value inside the optional, then that's true. So then I think all we have to say is contains 1. Test is happy. Add source test state test. Yeah, okay, there it goes. Oh my gosh. Test state. There you have it. There you have it, my friends. Or my friend. I think everyone else has left at this point, which I don't blame them slight. But I mean, come on, Astaroth. It's like 6 a.m. over there in Sweden. And Astaroth stuck with me this whole time. What a champ. Wow. That was brutal. I think what I shall do is I'm going to look at the solutions and compare, and then I'm going to call it a night. Yeah, thanks so much for your help. Man, really appreciate it. Oh, 7 there. Wow. So let's say, what do you have to teach us, Tony? Okay. Exec state K, second K. You can just pattern match like that? Oh, because K is a function. So given an S, K will produce some tuple, and then you get the second element. It makes sense. That's kind of cool, though. Eval. Yeah, first dot K. Get is the same solution. Put state composed with const composed with constructor unit. This looks very fancy to me. That's pretty cool, though. Oops. Ours is pretty succinct too, though. Instance for functor. Let at equals ks and fat. Okay, so he pattern matched on the state, which is, we just did run state. And then we did our bifunctor thing. State. Yeah, we're just applying f to the first value. I think I see that. See, applicative. State's the same. We just used our fancy tuple section there. And then state F, state A. So this, yeah, this pattern matching is kind of a nice way to do that because you don't have to do run state everywhere. FS, GT, AT, ZU. This lettering is kind of confusing to me. GZU. It's basically the same thing, just with pattern matching instead of run state, and then these different letters. Monad. Okay, pattern matching again. Yeah, same thing. Find M. Oh, he did pattern matching on nil, a nil list. And we did fold right. So if it's a nil list, pure empty, which is our empty case as well, nil case. If it's not nil, then you have a head and a tail. If Q, then pure full head. Else find, oh wow, he did a recursive version. So find M on the tail. You do the predicate. Okay, so you apply the predicate to the head. You bind that result, and that's Q, some Boolean Q. If that's true, then you return the head, pure full head. Else you find M on the tail. Wow. I mean, I guess that's what fold right does, though. It's, I don't know why that impressed me, but there is something nice about this solution. It's like clear. Our solution is not bad though. I guess maybe what's less clear is that this bind is happening inside this cons operation. Whatever. Okay, first repeat. List with state. Find M S member. List with state filtering S not member. Okay, so this is what we were talking about, how first repeat and distinct are the exact same except for here, S member instead of S not member. And I think what he did is he created this helper function, list with state, that takes a function and puts it in place of this function. That's really hard to read, in my opinion. SMT. Wow, lift 2s. Yeah. And then is happy. Contains one. Composed with first repeat. Composed with produce, two integer, sum, map, join. Wow, look at that. Just a string of composition. Yeah, so you show that you take some integer, you show it, and you map this over it, which is what we did. Square, digit to int, it's square. Then you sum, and then two integer. How come we didn't need to do two integer? We did from integer, whatever. First repeat. Yeah. Same solution, just he put it in like a single line like that. All right. Cool. Well, man, that was a journey. Appreciate you all being on the journey with me. No, that was really fun. I feel like every time I do this, I get an intuition I end up asking a lot of questions and getting a lot of answers to those questions. Yeah, this is definitely a brain twister. Trying to wrap my head around having stateful values in a purely functional way, I guess. But I mean, we put it to use here, you know. I think one of the light bulb moments for me was this find m, where this example specifically, where you have this list of you have this list A through H, the letters, and then there's a way to basically you're looking for C and then you're iterating on some count every time. I feel like that could have been highlighted a bit more, but yeah. Banana Pudding says epic light bulb moment. Yeah, that was pretty intense. I'm excited now to get to this next one, State T, which I will be doing tomorrow with Pete, who was on the stream today. So we'll look at State T, and there'll be lots of fun exercises. Oh man, it's gonna be tough. But yeah, thank you so much for joining. And if you hadn't had a chance yet, please follow the stream. That would help me out. And if you're watching this on YouTube, you could hit the subscribe and like button. Yep, I'm doing the typical YouTuber thing. And yeah, appreciate it so much. And I will catch you next time. Have a good night. Hope you get some rest eventually there. As Tarath. And Banana Pudding, thanks for joining. See you next time.